Another EE World Online EE Engineering Training Days. Thanks so much for joining us. Today, this is now a third in the series from our sponsor, GORE. We're going to be talking to the pros. So get ready. We're going to have this really great roundtable ahead, and we're going to learn what it takes to design electronics that can survive and thrive in the harshest environments. So get ready. But on that get ready note, I just want to let you know a few attendee tools. There are lots of resources that are downloaded and that you can download in the resource widget. Within those resources as well are links to the 2 previous EE training days that are complimentary to this third one. And you can submit questions in the Ask Question widget, by the way, at any time. By the way, when I say at any time, it also means if you are watching this on demand right now, no worries, ask your question. We'll address those. We're just gonna have a short presentation before the roundtable and we'll address them then. And you can expand the slides with the icon in the top right corner if you want to get the bigger picture. Now, if you should have any issues while you're attending here, just refresh your browser. It solves most of those. Try closing the other apps and browser tabs because they're bandwidth hogs. And there is a help in the top menu for troubleshooting steps. Hey, if all else fails, or even if not, you can ask for help in that Ask Question widget, the same widget that you'll be using to ask your technical questions of our technical pros. So don't worry, we've got you covered. Now, as I said, this is a roundtable, and we've got some really good conversation ahead of us. So I don't want to spend too much time on the bios, as I normally do, but just a couple of highlights, just so you know that we've got some great experts here. Michael Schindler, he's an electronics application engineer at GORE and Associates. He earned a master's degree in chemical engineering from TU Munich in 2015. And he transitioned to GORE as an applications engineer, leveraging his scientific and engineering expertise to support customers and deliver solutions. We also have with us today Timo Seibel. Timo is an applications engineer, also at GORE and Associates, with nearly 2 decades of experience in advanced filtration and venting technologies. Matt Gessner, he's a longtime professional engineer at GORE, a senior applications engineer with over, as I said, long-term, 28 years of experience in engineered venting solutions. And also joining us today as a special guest is Chris Shekovitz. He is an application engineer at Sealing Devices, and he has a Bachelor's of Science in Mechanical Engineering from Rochester Institute of Technology. By the way, Sealing Devices is a partner and distributor in the US for GORE. They sell their venting solutions and other GORE products, specializing in sealing and gasketing. They export sealing enclosures in a wide variety of shapes and sizes. Now, those were really abbreviated bios, but you can find those bios on the registration page and also in the resource center. So we are now going to kick it off with Michael, Misha. So it's all yours.
Thank you, Amy, for your kind introduction, and good afternoon to everybody. I'm really glad you could make it to our third and last session of the Designing Electronics for Durability series with EE World. So we are GORE. I hope you know us from our previous webinars, our venting products, or if you haven't heard of us from our venting products, perhaps you're familiar with the GORE tags for jackets and the shoes. So we are actually the GORE from GORE tags, and we also use our material science expertise to not only make vents, garments, but also cables that go into space, implants, medical implants that go into your body, or guitar strings that go onto your fingers. So today our focus is the topic how you can ensure long-term durability of electronics that are used in harsh and unpredictable environments. So I hope these pictures do not familiar with you. So we saw them. If you don't use proper venting, you can have moisture building up into a device, leading to corrosion, for example. You can have seal degradation, allowing ingress of water, dust, or salt, also leading to corrosion. And all of these factors can, in the end, compromise the performance and the lifetime of the devices. So if you are in the process of designing an enclosure or equipment in general for outdoor electronics, there are some questions that you might ask yourself. So what is the environment where I want to deploy it? Is this an accessible location? What is the expected lifetime of the equipment? Will there be regular maintenance required? And are there any constraints in size or in costs? Or do I have to fulfill any IP or NEMA ratings? So these are only some of the questions you might ask yourself, but for multiple applications, there can be multiple different other questions coming up. So before we start with our Q&A session and the panel discussion, I just want to quickly recap our last two webinars. And by the way, they will be on the EE Training Days website or gore.com if you missed them, so you can watch them on a later stage. 2 weeks ago, we were talking about the topic of moisture management. So without proper venting, you have the threat that moisture can enter an enclosure, even if you think it is fully sealed. And with the moisture in the enclosure, you can get the failure modes that I previously showed. But the vent can be a pathway for the moisture to leave. So the vent can really minimize the risk of condensation and help you designing and protecting the enclosure for a long-lasting lifetime. 4 weeks ago, we were talking about pressure equalization in general. So if you have an electronic enclosure, you typically will have temperature changes. Temperature changes can come from waste heat of the electronics or from daily temperature cycles or sun radiation. And as air will heat up, it will expand. If it cools down, it will contract. So these temperature and pressure differences can lead over time to a degradation of the seal, as the daily pressure cycles without proper venting are a real threat. And if the seal breaks, then this can be a pathway for these contaminants and seals. So you want to introduce a vent to protect the seal of your device and to enable really a longer last time. So today we'd like to also introduce another important design consideration, the selection of the gasket to seal the enclosure. So before we get to our Q&A, Chris from our technical partner Sealing Devices is going to give us a brief overview of some of the key questions and considerations they use when recommending a gasket material and design. And with this, I hand it over to you, Chris.
Thanks, Michael. I appreciate the warm introduction, and as well with Amy. As we heard in previous webinars, vents are key to eliminating pressure differentials inside enclosures and across sealing surfaces. And Sealing Devices is a separate company from GORE, but we've had a strong and long partnership offering GORE's industrial seal and venting products to new and existing customers. Sealing Devices offers a wide variety of seals and gaskets in the aerospace, industrial, telecommunications, and electronic markets. We both fabricate seals in-house at our Lancaster facility, as well as offer our partner seal solutions. These seals and gaskets are for extreme environments, including extreme pressures and extreme temperatures, as well as dynamic hydraulic seals and rotary oil seals. Today, we're going to focus on the requirements for design considerations for electronic enclosures. So just a quick overview outline of what we're going to go over. We're just going to go over seal requirements and then seal solutions that meet those requirements, and then talk a little bit about housing design. So understanding your customer's needs or what your design goals are is the best starting point to designing a proper seal or gasket, right? So what's the size of the enclosure? Is this a small RFID tag? Is this a medium-sized electrical panel? Is this a large server cabinet? Also, knowing the temperature range is important. So we need both the high and the low temperature. Is this like just a temperate climate, or is this going into an extremely Arctic environment or something like a desert? Also, knowing the pressure is important, or is this a water submersion requirements? So is this going in the vacuum of space, or deep in the ocean like in an oil rig? Um, if you don't plan for pressure, seals can blow out. And you can see in the lower right a blown out O-ring due to too much pressure. Fluid exposure is also important. So are we exposed to water, or is this also exposed to acids and bases and fuels and oils and alcohols or other fluids, right? So when we have benign basic requirements, we can focus on reducing costs, but not factoring everything in can result in long design times and multiple iterations of testing, which can be very costly. And you can see on the right an O-ring that failed due to chemical attack. Seal cycling is another consideration. Every seal will take a compression set, or the material will not rebound to the original size it started at. And knowing if a gasket is compressed and never opened again, or if this is literally a door gasket that's opened and closed as many times as possible, is something you need to consider up front. Knowing what an industry the part is being used in is also important. Are there NEMA ratings, IP ratings, UL ratings? Is EMI shielding a consideration? Knowing the type of testing is also important. Air testing can be done in a pressure chamber or pressurizing the housing and watching for pressure decay. And knowing that up front, you can make special surface finish requirements so that it will meet those requirements. So let's talk about seal solutions. There are three major categories I'd like to touch on. Extrusion, as shown in the upper right, there's a mishmash of different profiles there. We've got cut gaskets as shown in the lower right, and the molded gaskets as shown in the lower middle. Elastomer rubber extrusions are long, continuous cords that can be bonded into rings or miter-cornered frames. Hollow and lip profile extrusions are particularly good at gasket cycling and can offer lower closure force when weak housings and minimal load is available from hinges and latches. Gaskets are typically cut out of sheet or roll good, and materials can be foam or solid elastomer. For seals, we use closed cell foams, which can be used for basic water submersion. Foam can also offer lower closure force than solid elastomers, where solid elastomers can be used for strong chemicals or higher pressure ratings beyond environmental sealing. A solid elastomer gasket can get up to 150 psi of pressure, but requires much more compressive load. Any gasket material can be cut into almost any shape. Adhesives are another consideration, and they can be applied to gaskets and large extrusions. They can be helpful in door gaskets, or if the assembly of the gasket needs to be inverted, where it would fall out during an assembly. Some plastic housings do not bond well, so knowing if the housing is a low or high surface energy material is important to selecting this as an option. Molded gaskets are similar to die-cut gaskets in their versatility. These are almost always solid elastomer rubber, so it is important to have sufficient closure force. One advantage here is that metal features can be insert molded to either control the amount of compression or incorporate mounting locations for hard fasteners. So housing design, let's talk about that a little bit. First, how is the seal being compressed? Is it a bolted flange, or is this a door with latches and hinges? Second, what's the material? Is this a metal housing? Is it a plastic housing, ceramic, fiberglass, and are those walls thin or thick? Other factors to consider is how much is the gasket going to be compressed, and how strong is the material, and how strong are the bolts and the latches. If the bolt spacing is wide and the flange material is weak, the flanges can deflect and result in a potential leak. You can see that the flange deflecting in the lower left there. If you narrow the gap between the bolts, and if you soften the material and increase the strength of the flange, there'll be sufficient load to compress the seal and protect your electronics. So let's look at a basic housing, say something 6 inches wide by 10 inches long, and let's look at some of the options we've discussed. You can see in the lower left, there's a cross-section view of the door on the top, next to the seal, and next down is the seal, and below that is the enclosure itself. In the chart on the right, you can see we're looking at different seals in that groove shown in the section view. All of the options are adhesive backed. We have a compressed foam gasket, a hollow de-extrusion, and a solid de-extrusion. In the top row, we have the cross-section of just the door with the seal sticking below down below the groove. You need the seals to be larger than the groove for proper compression. In the next row down, you can see we've added the enclosure, and you can see how each profile is compressed. Then in the bottom row, you can see the total force to compress those seals when closed. And so for the compressed foam, we have 33 pounds or 147 newtons. The hollow D is a little bit more at 85 pounds. And then the solid D is the maximum at 400 pounds. So by incorporating vents in your enclosure, you can equalize the pressure inside. This ultimately allows a reduction in pressure across the seals. By reducing this pressure, you can soften the gaskets and the extrusions that require less load or force to compress them. These softer materials allow designers to use thinner flanges and less bolts, or potentially switch to hinges and latches for doors. Without vents, you need stronger seals and heavier enclosures to compress those seals. So over the course of the 3 webinars, we've discussed how WL GORE vents provide pressure equalization, condensation reduction, and now how they improve sealing capability. Hopefully we've given you an awareness of how vents solve so many different problems. And again, thank you for the opportunity to present today. And I will pass this back over to Amy to open the question and answer portion for all the panelists.
Great. Thank you very much, Chris. If we can have all of our panelists join us, we are going to jump right in. And audience, let me remind you once again that you can ask a question at any time. I'm going to rapid fire some questions at the panelists right now. And a couple of these have actually come up from an audience in the past, but now we've got our 4 experts with us. So this one, Timo, is for you. In your experience, what are the most common failures that you see?
Thank you, Amy. That's a great first question. So from my perspective, I would say the biggest challenge for outdoor electronics is that you have to maintain their integrity over their whole intended service lifetime. And common failures that we are seeing, and we have already seen some of them at the beginning when Michael kicked us off. Common failures are, for example, water ingress, and that can happen due to a failure of the gasket. But also condensation is one failure we are seeing really often. It's when condensation forms inside the enclosure, and that's typically caused by rapid temperature changes. Another one I would like to highlight here, and that's more on the long-term side, it's degradation of certain materials. And if you think about the gasket, but also about the housing, so if you have like a plastic material, and that can degrade from sun radiation. So it's really about the selection of good plastics that are stable against UV. They are UV stable and resistant in this regards. And all of these failures, they can lead to that the electronics inside corrode. They can create short circuits of the electronics, and with that, eventually lead to a failure of the whole electronics. And as we heard, a very simple method to avoid these is to have a pressure equalization vent. This will balance the pressure, protect the sealant, and at the same time maintain the moisture, manage the moisture inside, and reduce the risk of condensation inside the enclosure.
Okay, great, thank you. And but on that note about condensation, so how do you, if we can elaborate, and this is for Matt or Mishi, how do you prevent it? So if my enclosure is fogging already, how do I stop it at this point?
I guess I can start, and then Matt, perhaps you can continue with it. So actually preventing the condensation is a very tough topic because you need to consider multiple options. And you also have to be aware that condensation is a natural phenomenon. So we are typically say we can minimize condensation, but not prevent it with our vents. And how can we minimize it? So by placing the right vent in the right position, you can allow the moisture to leave the enclosure. And therefore, then if you have a cool down that would result in the condensation event, there's not enough moisture left to really condense. So this way you could prevent the condensation in this specific scenario. To actually prevent it, you would probably need an additional method like a heating device that prevents the rapid cool down that would create the condensation. Matt, anything you want to add?
We're just going to take you off.
You're on mute, Matt.
I lost you. All right, well, I apologize. Yeah, certainly. The vent allows any water that's trapped inside an enclosure to escape. And if you have a fully sealed enclosure, that water will just stay in there. And you think that even with a sealed enclosure, there's no opportunity for water to get through, but there is a permeation rate associated with elastomers. Even some of these lenses, water can permeate through that. So a vent can manage moisture, reducing the events of condensation by allowing an escape for that water vapor inside.
Okay, great. Thank you. Then I think I'm going to send this back to Timo. So let's talk about materials. Will metal create more heat and pressure issues than plastic?
Good question, Amy. Assuming we are talking about the enclosure material, and when it's made of metal, so yes, you can expect higher pressure peaks in a metal enclosure compared to a plastic enclosure. And the reason for that is metal has a higher thermal conductivity.
Right.
And with that, it responds faster to temperature changes. And you know, heat will transfer faster in to the metal enclosure, but also out. And with that, the peak, but also the speed, it will just a higher swing in pressure within the metal enclosure compared to plastic enclosures. What I can also add to this question is that we have the possibility with our simulation tools to also simulate how the pressure behavior will be in a metal enclosure compared to a plastic enclosure. So what we can visualize is the pressure development within those, and also it shows then the impact of the material. But also then we can include the performance of a vent and how that will like reduce the pressure. And with that, we have a good method to, you know, visualize the different behaviors, but also recommend then a suitable vent solution for that certain enclosure, no matter if it's made of plastic or metal.
Well, that will take the guesswork out of it, and that guessing can be very expensive, right?
Absolutely.
And so we're talking about a little bit about, there was some mention about some temperature cycling and compression. So Chris, this one is for you. So we're talking about gasket materials. Which ones hold up best under temperature cycling and compression over time?
Yeah, that's a great question, Amy. So like silicone and fluorocarbon materials are really good at handling temperature. So if you need extreme temperatures, those are the ones we usually lean towards. And they also tend to be better for compression set resistance. And so kind of what I spoke about during the presentation was, you know, if you squeeze an elastomer and you heat it up and you cool it down over and over and over again, it will take a set and it won't rebound as much. And so picking an elastomer like a silicone or a fluorocarbon that can handle the temperature allows it to continue to have that elastomeric property and bounce back and seal properly for you.
Okay, great, thank you. And this one's back to Matt. So I know we talked a little bit about venting, pressure venting in the last webinars as well, but specifically, how do I calculate the amount of pressure venting I need? And how do I size a vent correctly for my enclosure? Again, we want to take the guesswork out.
Yeah, absolutely. And Timo mentioned it. We have a way to model enclosures, a simple model that tells us about pressure response. And the inputs to that model is the size of the enclosure, the materials, how much free air space is inside. And from that, we can look at the response of pressure going through various temperature changes or even altitude changes. If you have an enclosure that's going to be air-shipped, or if it's on an aircraft, we can model that. And the response we would look at and see what the peak is with a sealed enclosure. So if you did not have a vent, what you would have to cycle to, or with different vent options, and what your peak response will be. And if you don't know what your design can handle through the process, we typically would recommend about a half PSI limit for most design. This is where someone like Sealing Devices, like Chris here, can also be a great consultant on with this particular design. Is there features that we can add to either increase its resistance to pressure, or to allow maybe a less expensive option with the vent that would be chosen. So we can model that and then also add some potential to cost savings.
Great, thank you. And just a reminder to the audience, you can keep asking questions, but I'm going to go back to Mishi then. So how much does the temperature have to drop to create condensation?
This is a great and an important question, Amy. So let me pull up a slide that I used for my moisture management topic last time. So the amount of moisture that air can hold depends on the temperature. Warmer air can hold more temperature, and colder air can hold less temperature. Okay. So if you think about a pressure drop of, let's say, 5 degrees, it really depends if the pressure drop is coming from a very high temperature to still a high temperature, or from a low temperature to an even lower temperature. So for the high temperature, it's probably not that critical, as you would need a really high relative humidity in the first place, so that the pressure drop will, the temperature drop will lead in condensation. And for the lower temperatures, you would probably need less relative humidity to have an impact for the same temperature change. So you cannot really give an accurate answer to this, like, yes, it needs 10 degrees to create condensation. So it really depends on your environmental conditions, the temperature, and the relative humidity you have.
Okay, that makes sense. Thank you. Okay, next question. This is back to you, Mishi. Is so we're talking about harsh environments here. So what's the best vent option for an enclosure that needs to withstand high pressure jet cleaning with cleaning chemicals? I mean, that's pretty harsh.
Yes, that's pretty harsh. The high pressure jet, so there's typically a standard to this, IPX 9K. So this is high pressure jet with 85 degrees C at 85 bars and a distance of 10 to 15 centimeters. So really harsh water spray. And we actually designed some of our vents to withstand these conditions. And again, so here on this slide, you can see our newest vent, and it has a protective cap on top of it. So this cap really protects from this, protects the membrane from the water pressure, from the water spray, and also with the chemicals coming with the spray. So for these kind of applications, I would really recommend to use one of the molded vents that have these protective caps that are particularly designed for these kind of applications.
Okay, great, thank you. All right, so Timo, attendees asked what my design includes a microphone port. Can I use the port for venting too, so I only have one opening? Sounds like legit. Or will it affect sound performance?
A good question, Amy. Thank you. So this is related to acoustics, and the short answer is no, we would not recommend it, and yes, it has an impact on the sound performance. So we differentiate between pressure vents and acoustic vents. And pressure vents, they are really good in equalizing pressure. They can manage a huge amount of air, but they are not really good in sound transmission. But for that, and I mentioned it, we have developed vents that are specialized and optimized in sound transmission. We call them acoustic vents. And they have a good sound transmission because they are reactive in their behavior. So they will vibrate with the sound waves. And with that, they transmit the sound waves from one side to the other side. But at the same time, they also have a really good protection against water ingress. And those vents are typically used for acoustic ports like microphones.
Gotcha.
And definitely, so our recommendation is we want to differentiate between the port for venting. It has its own pressure vent, but then also an own individual acoustic vent to protect the acoustic port.
Thank you, Timo. And audience, by the way, there's even more information on the acoustic venting in the previous webinar. So remember to check that out if you want to elaborate upon, if you want a little more elaboration upon that. But let's
if I could add just one other comment to that. As to Timo, he's right on with the desire to have a separate pressure equalization port from the acoustic port, and that's for high acoustic quality. I have dealt with some buzzers, so just a simpler alarm, which I've seen people try to double up for a pressure vent. It's possible. I think a simple buzzer or alarm, you're not as concerned about the audio quality. But for a lot of the applications that Timo and I and the rest of our team come through, you want to have the best sound quality. And so by separating the pressure equalization need from the acoustic protection, you're going to gain that. But putting them together, you're going to sacrifice something.
Yeah, it's dangerous to have it do double duty, in other words. Gotcha.
Yeah.
Okay. Hey, Chris, back to you. Next question is for you. And they're asking, how do I prevent gasket fatigue or loss of sealing performance?
That's a great question, Amy. So a lot of people feel that to get the best seal, you need to squeeze it as much as possible.
Mm-hmm.
And actually, in a lot of cases, you want a minimal amount of compression, just enough to get it to seal. And thereby, it doesn't take as much of a compression set. And so therefore, it can have a much longer life. And so really understanding how much pressure you need to seal, how much you're going to compress the gasket, how hard the gasket is, kind of all the things we talked about, incorporating all of that, and then getting a material that is designed for compression set resistance. So again, we talked about silicone and fluorocarbon. Those are good. Urethane is also good, especially if temperature isn't a factor. Urethane is actually one of the best materials to avoid compression set. So all of those things go into the life of a seal. And then you still have to factor in all the chemicals and the pressures and so I would say factor everything in, select something that's got a good compression set resistance, and that'll give you a long life in a seal.
It almost seemed counterintuitive to me to assume that like less compression could actually be better, but it sounds like
right.
Yeah, okay. All right.
In some cases it is. In some cases you don't want to overcompress the seal. I know you can actually, for a rubber gasket, you can actually squeeze it so much that it fractures, and that's no good either.
Thanks. Okay. All right. Okay. I think this next question is for you, Matt. What are the limits of exposure for typical enclosure materials? How long can they withstand UV, salt, spray, or chemical environments before you see damage or issues?
Yeah, thanks. So when you're talking about most of the common metal enclosures and the ones that are powder coated, they essentially have very long life. They're not going to degrade for the outdoor environments that we would typically see in our applications. The plastics, that's where you need to be more mindful about how the UV and the thermal characteristics are on the material. If you're not using a vent, then you're going to have a lot of flexure going on in the plastics. So, for example, in outdoor street lighting, which can incorporate a vent, it has in many cases, they've gone away from glass to acrylic and even to silicone lenses, and they can degrade, especially when you add some pressure reflexing of the silicone. They can actually deform the light beams. So those are things that are maybe unique to, say, a street light, but perhaps with some LiDAR, some other devices that have lenses. So from a UV point of view, you want to look at the UL, I think it's 746C, that talks about the longevity of materials when exposed to UV. I believe it's 1,000 hours in the test, and that projects out the lifetime, of the device to several years. And for thermal cycling, you want to look at the high and low temperature cycling and dry, like hot and dry, as ways to look at the material and how it performs over long periods of time. We've done this with our venting materials, but you would look at the plastics, the ABS or polycarbonate materials for those same properties.
Okay, great, thank you. So then, I'm not sure if this would be a Chris or a Matt question, but the attendees ask, is a fully sealed small PC plastic enclosure like an RFID tag with minimum air volume inside, is that susceptible to condensation in an outdoor environment? Who would like to chime in there?
I will. I say yes. If you're in the right environment, and you'd have to have a same amount of outdoor moisture over time, and you could have water vapor inside the enclosure and then cool it off quickly. So let's talk about a RFID tag that's, say, on a package that goes into a refrigerator or freezer, and it's been sitting in a fairly hot, humid trailer being shipped, and then it goes into a refrigerated unit, then you could get condensation. It's really about the environmental conditions and less about the volume of air. Now, what we can do is use a larger vent that will allow the water vapor to escape quickly enough that the condensation will not have time to form, and allow the vapor to escape before that temperature drop of the material occurs. I don't know if you have anything to add, Chris. I think that one is more of a venting question than a seal question.
Absolutely, but you knocked it out of the park. I don't really have a lot to add, but yes, you can get condensation in a small enclosure, and adding, like you said, having sufficient venting to get the condensation out is key.
Probably what is less likely is with a large device, you have the possibility for temperature to be different in a large device, say a large cabinet, where you may have a colder spot on the bottom and a warmer spot on the top. Because of the electronics inside. With a small tag, you don't have that possibility. So it's less likely for sure than a large device or some stylized device like a long tube or something that has some unique shape. So that's where your advantages with a smaller RFID tag would be.
Okay, great, thank you.
Perhaps I can, Amy,
yeah, please.
I can add also something to this question, because it was also part of my webinar. So if I read it, it's fully sealed. So you could think that there is no way for the moisture to get in. But if we talk about polycarbonate, there is actually can be some amount of permeation. So moisture going into the enclosure, and then it is inside, and it can lead to the condensation.
Okay, great. Thanks for giving us the big picture there, all of you. So, all right, let's move back on. We've got a question here. I think this is for Chris. Can I use an off-the-shelf electronics enclosure with the gasket already installed? Doesn't it already have an IP rating? Why do I need a custom seal? I'm already seeing red flags, but go ahead.
Yeah, so I mean, you can use it off the shelf, but does it meet all the requirements, right? So, does it meet your chemical requirements? Is it, did they just use a basic elastomer that's, very economical so they can sell more units? And it's probably not going to have great compression set, and it's probably going to fail pretty quickly. And this kind of, I wanted to share this at some point, but if you have to value the electronics you're designing, right? Like, whatever it is, if it's a power unit, if it's, you're designing something that's somehow critical to somebody, and if you have just a poor seal in there, you're going to end up, it's not going to work. And whether that's a piece of equipment that's down, or you know, some sort of communication device that suddenly you can't communicate with somebody, whatever the electronics are, you know, they're very important, and if you don't seal it properly, that's a problem. So yeah, you can use a generic off the shelf, but I would be very, very hesitant to know that that person planned to give you the best seal for all the requirements that you're probably going to need in your application.
Yeah, it sounds like risky business, because you really don't want to wait until something fails. I mean, all of that engineering expertise and design that went into the product is just out the window. So
right, exactly.
Yeah. Okay. All right, Nishi, I think the next question should be for you. How do I know if my vent is working properly after installation?
Thank you, Amy. Yeah, also good question again, and I've heard it a couple of times. So, of course, customers want to install our vents, and then they want to check if it's working properly. Mm-hmm. So we have one recommendation to check that it is working properly and can equalize the pressure. And you can also, as a benefit, measure the tightness of the enclosure that is incorporated. So therefore, we would recommend that you would give a positive pressure, or perhaps also negative pressure, through our vent into your device. So therefore, you can see that the airflow is working through the vent, and if you have the positive pressure, and you can disconnect it, you also see that the enclosure is fully sealed if you still have the port on top of the vent. So, and if you then remove the port, then the positive or the negative pressure will be again equalized through our vent. So therefore, you will see that the pressure equalization works after installing the vent.
Okay, so then I guess my follow-up question would be this, like, well, are there guidelines then for vent maintenance or replacement over time?
So typically, we say that our vents last the lifetime of the device, so typically more than 10 years. That being said, of course, there can always be some specific environments where you need to take a closer look. And if you think that you have such a specific and very harsh environment, please feel free to reach out to us, application engineers. That's why we're here. And we are very happy to support. Perhaps Matt, you can, and also, or do you want to say something from the US perspective for this question?
Yeah, thank you, Michael. Yeah, we've had some vents come back that's been almost 20 years of the device being in the environment. It's, you know, we have a paper that's out there that we've actually bought back devices from telecommunication that was well documented at 10, 11 years, and there was no degradation to the vent. We can share some of that, but from your summary was, as long as the electronic device is operating, the vent operates as well. So yeah, it's no different than what your experience has been, Michael.
Great, thank you. All right, so just throw this out to all of you. What are some things that customers have done that you've seen that haven't worked? So our attendees can stay away from them.
No vent. No, and actually that's serious. I had a customer who came to me. They were putting a fairly small box for an RFID tag that was mounted outdoors, actually went on ships and trucking, and they were failing. They were failing at a more than 5-10% rate, and failing by water reaching the O-ring. They had a laid-in custom O-ring. And it turns out that they were getting a pressure spike from sun and water splashes. we placed a vent in there and solved the sealing problem. And that particular customer said to me personally, I think we saved their business because they were starting to replace parts and not understand why. And once they installed a vent, and it was a retrofit, they would have parts come back and refit the part with the vent and then send it back out. They were able to get the long life, the many years of life that they were shooting for. So in all seriousness, in that situation, they did not have a vent, and that was a mistake that was somewhat costly.
And anyone else want to share any experiences that you've seen customers do things that just didn't work?
Yeah, I can add on and
go ahead.
Similar to what Matt said, and this is a field experience from a customer which is up north in Scandinavia, and that was about street luminaires. So they have rolled out a whole village with street luminaires, but they have not considered a vent. So I think it was after like roughly a year in the field, it started that the seal really failed. And then there also was a big project to retrofit with a vent from us. A lot of maintenance, but we were able to find a solution for them, and we're also able to keep the installed luminaires in the field, and retrofitted them with a vent, and then the pressure was equalized, the whole story which we were telling. Pressure was balanced, gasket was protected, and with that also the reliability was there and increased. So yeah, we have these stories from time to time.
Yeah. Anyone else want to chime in before I move on to the next question? Are you just going to let your customers off the hook?
I can add to this. So not just use a vent, but place it properly. And so place it in a place where it can work. So I got the feedback from a customer who actually used a vent, but from the placement, he had his main compartment, and then there was a long tube at the side of this compartment, and he had the vent on top of the tube. And in addition, as he wanted to have the tube as dual function, he placed a metal rod directly into the tube, leaving only a very tiny gap between the metal rod and the wall of the tube with a very long pathway. So this way there was almost no connection between the main compartment and the vent. And he experienced some condensation because the moisture couldn't get through this tiny gap and was still trapped, although he was using a vent.
Okay.
And a similar situation, a customer in my world had placed a label over top of the hole for the vent, thinking that the whole, the vent would still operate, and their outdoor, whatever their product label was over top of the hole. So it's important to make sure that the process, whoever knows about labeling, knows that those holes are there for a reason.
Oh, I wouldn't have thought of that one. Wow. Okay. All right. Well, thank you for sharing those experiences. We're going to get to a couple more questions before we still have time before the top of the hour. And then I want to get some final words from you also. I want to leave time for that. But all right. So this is also, anyone could ask this one. Where should I position vents to minimize risk of water or dust ingress? And a little bit was addressed here just recently, but what anyone here can chime in. What's the best placement?
I guess as I brought up the topic of placement, I can take this, and I will again pull up a slide from my webinar. So in general, we would recommend to place it on a vertical wall. So if there is some water, it doesn't pool underneath the cap, and it will easily rinse off. And if possible, we would also recommend having it not directly at the forefront where everybody can easily access it, and perhaps some workers might wonder what is this, and they might stick their finger into a membrane, but perhaps you can place it on a more hidden position on the side or on the back where it still can work properly, but is protected from the external access.
No, that makes sense. Makes sense. All right, well, let's keep moving here then. Chris, this one is for you, I believe. How does compression set impact long-term sealing performance, and how can I minimize it?
Yeah, so you definitely want to control the amount of compression that you squeeze your seal. We touched on it a little bit earlier, but if you over compress the seal, then you're going to squish it. And maybe let me jump to the slide here. So you can see in this slide, the seal, we have grooves designed so that when you squeeze it, it doesn't completely crush it. It stops. So there's a hard stop to prevent overcompression of the seal. And that's the case in each one of these, whether you're doing foam or an extrusion or any type of gasket. You want to control the amount of compression. And then, so again, selecting the right elastomer, right? Like there are compounds out there that are specifically designed to reduce and not eliminate, but highly reduce compression sets so they bounce back. And urethane, silicone, and fluorocarbon are key solutions to doing that.
Just out of curiosity, and we talked about some materials earlier, metal and plastic. Is there a premium on these materials? I mean, how do you decide if you need to keep it a lower cost? Do you take the chance that you just go on a material that maybe it won't have the same performance, or are they all about the same price performance level?
Yeah, so urethane and silicone are relatively economical. Even fluorocarbon isn't that bad. There are premium compounds out there, but I would say generally these are all at about the same level. And I will have to say that when I compare my elastomer cost or my seal cost against a lot of these electronics, it's such a small factor that it's almost a non-factor against some high-end electronics, if it's a radar system or a communications device, or, in a lot of cases, the electronics are way more. So just spending just a few pennies more on a gasket is kind of inconsequential.
Yeah, maybe I was subconsciously trying to underscore that. Is like, just spend that money because you've got this very expensive device that you can't have ruined because of one small thing. All right, we have a time maybe for a couple more questions. Maybe just one more. So there is a question here about the UV exposure, but we talked a little bit about that. So I'm going to end with this one. Mishi, how do I choose between different vent technologies for my applications? And I would recommend the audience check out the venting webinar, but if we could address that right now, how do you choose between the different technologies?
Great questions. So it mainly depends on your application and how much space you have and what you want to do. So the two main dividers would be, from my perspective, are you looking for pressure equalization? Then I would look out for a vent which has a very high airflow membrane, so you can minimize the internal pressure peaks. And airflow is key to that. When we are thinking about moisture management, then the airflow is not that important anymore, but the size is more important. So you want to choose a bigger vent, perhaps an adhesive vent, that you can place on the right spot where you need it. Other than that, there are factors like what kind of IP rating do you need? As mentioned, the one with the caps are more robust for the water spray. Then we have laminates, which are also rather fragile but have a very high airflow, or we have more robust membranes with a lower airflow. So it really comes down to the application. Where do you want to put it, and what's the environment where you want to put it? What kinds of challenges do you expect, or what are the requirements? So unfortunately, I think there is no one size fits all, but yeah, it really depends. That's why we're here also to recommend.
Application specific. Well, listen,
Yes.
Gentlemen, I want to give you each an opportunity to just have a few closing remarks. I remember, audience, this is third in a series. There's a lot covered here. There was some great advice, some solutions to some challenges. But let's see. Who should I pick on first? Matt, how about you? We want to just give some closing thoughts, and if that's advice or if that's, beware of this, or whatever you'd like to say right now.
Absolutely. Yeah. The idea that you're going to drill a hole into your nice sealed enclosure and then put a vent on it to keep out the water and dust sometimes can feel unnatural. I talked to some customers and they just say, well, why am I going to actually breach my nice and sealed box? But in reality, your sealed box is only as good as the seals themselves. And that's why, someone like talking to Chris, knowing what the limits of those are is really helpful. So it may seem unnatural, but we have been doing this for many decades. And by placing a barrier for dust, dirt, water, and then keeping the pressure low on those seals, the stress low on those seals is really critical. And this is where you can extend the life of your device inside, the electronics inside, by doing that, by allowing us to provide a venting solution.
Good advice. Hey, Timo, how about you? Last words?
Yeah, thank you. Yeah, so first of all, thank you for listening, giving us a chance to present here. But then also, I think I want to say, please don't hesitate to get in contact with us. We are here to support you. So if you want to integrate a vent, you need some support, we are happy to collaborate with you, get in contact with us. And then we will support you and find the right venting solution for your specific application.
Thank you. Hey, Mishi, your turn.
Yeah, thanks. So I would say I'm allowed to say this as I'm probably the youngest in this group. So when I joined GORE and discovered venting like a little child, I was really amazed on how many applications it is. So from street lights to auto, so to cars, to smartphones. So there are many applications where you can use the vent, and I would guess there are many more applications out there that I haven't heard about. So if you have any applications that we didn't touch, or please also think about it. Hey, can it actually help me, or should I use the vent? So it really can help all kind of products.
Great, thank you. Hey, Chris, our special guest, final words.
Yeah, thanks for having me, and thanks for including sealing devices in this. I think incorporating vents makes sealing a lot easier from the standpoint that we can equalize pressure, and we don't have to worry about the barometric pressure, altitude changes, all the things that vents solve, condensation. So, feel free to contact sealing devices as well, and myself. We're here every day. We answer customers' problems, and so if you need vents, if you need seals, we're here for you. And don't underestimate the seal, and don't underestimate the use of the vent. They really do help out in so many cases, and we see them at, like Michael said, in all sorts of applications. So you're like, oh, I don't think it's going to be, I don't think that it's really used in my application. It probably is, and you probably just don't even see it. So, keep an open mind, and, we're all here to help.
Oh, great. Thank you. I will have to say, personally, I wasn't aware at the level of sealing and venting that was necessary, because I cover so much with like the guts of the product, the electronics within it. And it's far more critical than I ever realized. And I learned a lot, and I'm going to go back and listen and learn even more. So audience, I would suggest you do the same thing. In the meantime, if you're watching this on demand, go ahead and ask questions. We also have a short survey if you get a chance to do that. Remember that this webinar will be available on our website, eetrainingdays.com. It's also available on gore.com, all of them, by the way. So definitely check those out. And the presenters' bios are there for you to see. I would strongly suggest that you link in with them. That would be great. And I think it's a really good note that we make here about if you have an application that maybe wasn't mentioned, or you don't even think needs sealing or a vent, definitely reach out to these guys, because I have found in my experience that when a vendor or manufacturer or supplier are sometimes surprised at the applications of their products. And I think it's really good for them to know going forward what those are and how they can work with you on them. So I strongly encourage you to do that. They're very open to your questions. Again, if you're watching this on demand, go ahead and ask those. Go ahead and link in. And by the way, gentlemen, thank you once again. And for all of the 3 webinars. Chris, thanks for joining us as our special guest. And audience, thank you for joining us on EE Training Days. And by the way, this is the last one for the year. We will see you in 2026 with a lot more. This is Amy Kilnoskis, Editor-in-Chief of EE World Online, signing off. Thanks so much.